Okay, again for ADMAT's chapter is coordinates, and today we're going to be looking at something that is not very new to you because you've done this in grade 9. We need to find the equation of the line joining points A and B given their coordinates. And now this is very familiar. For you to be able to find the equation of a line, the first thing you need is a gradient. Once you've got your gradient, you need a coordinate. The coordinate we have is any of those coordinates, minus 1, 3, or you could take, let's say, 2 and then 12. To find the gradient, we use gradient as m, which is y1 minus y2 divided by x1 minus x2. And now you may call this x1 and this one x2 y1 and this one is y2. So then we have y2 minus y1, which is 12 minus 3 divided by 2 minus 1. So it's going to be 9 over 3. So the gradient turns out to be 3. Once you have your gradient, the equation of the line is always a straight line, y is equal to mx plus c. So we're going to bring in y is equal to mx plus c. So this turns out to be y is equal to 3x plus c. Why 3? Because m is the gradient and m was found to be 3. And the next thing, like I said, we need one of those coordinates. So you're going to take either this one or that one. So I'm going to go with the easier one, minus 1, 3. So what we're going to do, we're going to substitute minus 1, 3 into y is equal to 3x plus c. So then this is x and this is y. So y is 3 and then x is negative 1. So 3 times negative 1 plus c. So we have 3 is equal to minus 3 plus c, and c is equal to 3 plus 3, c is equal to 6. So the answer to the question is then y is equal to 3x plus 6. So this is your answer to this question. And this is how we go about and find the equation of a straight line. So the next thing we're going to be dealing with is the equation of a line which is actually parallel to this line. So why don't we just do it right now? So let's say, for example, now I'm going to give you some time to copy this. And in the same question here, if I say to you, let's that was the equation of a straight line. Equation of a straight line. So now we have equation of parallel lines. Now remember, parallel lines have equal gradients. So I may say that if I want to find the equation of a line parallel to this line, let me just put it over here, find the equation of the line, the line passing through, let's say, minus 3, 7, and is parallel to the line AB. So here's the line AB, and as another line is parallel to the line AB. So let's suppose this is the line AB, and there's another line parallel to it passing through a point, and the point has been given as minus 3, 7. So we have a point, let me just call the point P, minus 3, 7. We need to find the equation of this line, which is parallel to the line AB. We understand that parallel lines have equal gradients. So what we're going to do is we're going to just call in y is equal to mx plus c. So the equation of this line, will be an equation where the gradient will be the same as the line AB. AB, the gradient of AB was found to be 3 over here. So this one here has gradient. The gradient is 3. And this one here has gradient. The gradient is 3. So we then say that this is y is equal to 3x plus c. And now what we're going to do, we're going to just substitute the point P minus 3, 7. So we're going to substitute, okay, minus 3, 7 into y is equal to 3x plus c. So this is x and this is y. So wherever you've got y, and y is 7, so you just put in 7 here. And for x, which is minus 3, so 3 times minus 3 plus the c, turns out that c is going to be equal to 7. Minus 3 times 3 is minus 9. When you send this on the other side, it becomes plus 9, which is then 16. So the answer to the question then, therefore, this line over here has equation y is equal to 3x, where 3 is the same as the gradient for the previous line, plus c, and c turns out to be 16. So this is how we go about and find equation of a parallel line. So we've done two things here, equation of a line and equation of a line parallel to that given line. And here we are, take care. The next thing is I'm going to be dealing with is equation of a perpendicular line. Bye-bye.